Alright, so as you can see, in this lesson we're going to discuss solving equations by adding or subtracting. Basically, balancing each side of the equation. So before we've worked with the additive inverse, we know that when you subtract, you're basically doing the opposite of adding. And today we're going to go ahead and solve equations using those properties. We also want to be able to translate verbal sentences into equation form. So just some vocabulary you want to make sure you're familiar with. An equation is any mathematical sentence that contains an equal sign. So when we set two things equal to one another, we're balancing them. That's our goal. We're going to balance these equations. A solution is a value for a variable that makes an equation true. So both sides, if they're equal to each other, if they're the same, that's the solution we put in for a variable. Solving the equation is that process of finding a solution. An inverse operation, I kind of mentioned that at the beginning. With adding, your inverse is subtracting. With multiplying, your inverse is dividing, and vice versa. Finally, an equivalent equation is an equation that is the same or has the same solution as your first equation, your first number sentence. So our key concept here that we want to look over is the addition property of equality. If you add the same number to each side of an equation, the two sides stay equal. For instance, let's just say you have $5 and your friend has $5. You have an equal amount of money. If somebody gives you $4, you now have $9. If they also give your friend $4, your friend also has $9. You've both increased your amount by 4, so you both still have the same amount. And as you see in this example here, we know 4 equals 4. So say you had $4 and your friend had $4. If you add 9 to both your totals, you're going to end up with 13. The equations stay the same. What also is nice for us, if we don't know a variable, like y for instance, we have y minus, we know y subtract 5 equals 10. Well, you might be able to instantly figure out that that's 15, because we know 15 minus 5 is 10. What you were doing in your head, you were using what you know is the additional property of equality. You were adding 5 to 10 to kind of work backwards. And that's all we're doing when we solve equations. We're just adding 5 to each side, because what happens for us is we get rid of that minus 5 here. And don't worry if this is a little confusing right now. We're going to look at some examples and the process of doing this. But basically, the addition property says if you add the same number to both sides, the sides stay equal. So let's look at an example here. Solving equations by adding. We have x minus 4 equals negative 3. So what we're going to do, we're going to use our addition property of equality to do what's called isolating the variable. If we're going to solve for x, this variable, we want it to be on the side by itself. So to get x by itself, I'm going to use this trick to get rid of the 4. I'm going to add 4 to both sides. Because what happens is, if I have negative 4 plus 4, that gives me 0. I still have this x here, so I essentially have x and then a 0 equals, on this side I added 4, and I get negative 3 plus 4. Negative 3 plus 4 is 1. If I have x and I add nothing, I basically have x. So x plus 0, remember your 0 property of addition is, or your identity property, is just x plus 0 is x. And that is equal to 1. What we can do is check that. So let's put 1 in for x. Is 1, we put 1 in for this x here, is 1 minus 4 equal to negative 3? Well, it is, because you take, if we make a number line, we have 0, and we'll put 1 here, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So I start at 1, and I go back 4. So minus 4. 1, 2, 3, 4. I ended up at negative 1, negative 2, negative 3. So our answer is good. X is equal to 1. Alright, so let's take a look at the second example. We have negative 8.4 equals n minus 6.1, and we want to solve that for n. So we have negative 8.4 equals n minus 6.1. Again, to get n by itself, I'm going to use the addition property of equality. If I add 6.1 to both sides of the equation stay the same. They don't change. So now we have these two cross out to give me 0. So we only have n on this side. On this side, we have negative 8.4 plus 6.1. So different signs, I'm going to subtract and keep the bigger sign. So let's take 8.4 minus 6.1. We're going to get 3 and 2. So it's going to be negative 2.3 for n. So n is equal to negative 2.3. If we check that, if you put that in your calculator, you get 2.3 minus, negative 2.3 minus 6.1. You should get negative 8.4 for your final answer. And on a number line, if we have 0, we'd have negative 1 and 1. So negative 2, it's a little bit further than negative 2, but not quite to negative 3. So on our number line, it would be about right there or so. So that's what it would look like on a number line. Alright, now you want to make sure you pause the video and answer the little quiz question on the video. And now we have a second question here, and I'm just going to give you another opportunity to pause your video. Alright, so now hopefully you've answered those quiz questions. We have another example here, or another property here. It's very similar to the addition property. Basically, if I subtract the same number from each side of an equation, the two sides remain equal. I always like to use money for examples to see how these work. Say you and your friend both have $7 apiece, so you have an equal amount of money. 7 equals 7. What if you had you bought a few bars of candy in a fundraiser that cost you each $3? If you both lose $3, you're still going to have the same amount of money. And that's how all math works. If you subtract the same number from both quantities that are equal, you're still going to end up with the same number. And as you can see, you can start to see now we're solving equations. If we have n plus 4 equals 9, and I subtract 4, that 4 and the negative 4 are inverses. They cancel out. They add to 0. So I have nothing but n on the left. 9 minus 4 gives me 5 on the right. So an example, we'll use the subtraction property. We have 32 equals y plus 12. Let's get the y by itself. So we're going to use the subtraction property to subtract 12 from each side. And we get these to cancel out. We just have y on the right. 32 minus 12 gives me 20 on the left. Now checking my solution, is 20 plus 12 32? Indeed it is. So always remember to check your solutions to make sure that they're reasonable. Now let's look at this example. We have x plus 6.9 equals 4.2. I'm going to go ahead and subtract 6.9 from each side. It's going to cancel my 6.9s on this side, so I only have x. But on this side, let's go ahead and take 6.9 minus 4.2. we get 7 and 2, so 2.7. The bigger one is negative, so I'm going to keep it negative and make it 2.7. So x would be 2.7. Wouldn't it make sense that if I'm adding a number to 6.9 to get 4.2, it would have to be a negative number? So if I have negative 2.7 plus positive 6.9, I get positive 4.2. Alright, so go ahead and pause your video. Make sure you answer this question before you move on. And then while you're at it, pause for this one as well and answer it. Alright, so we have this word problem here. Driscoll Mountain, with a height of 535 feet, is the highest point in Louisiana. It's 8,214 feet lower than Guadalupe Peak in Texas, which is the highest point. Write and solve a subtraction equation to find the height of Guadalupe Peak. So I've already written it out here. We know that Guadalupe Peak is the bigger one. So we're going to take away 8,214 feet from that to get to Driscoll. So if we just draw a little diagram here, we have Driscoll, which is 535 feet. And we know that there's some distance, 8,214, between Driscoll and Guadalupe.